Okay, so this revision video is about P2 again, and it's about climate change. Now, climate change is all really to do with irradiation such as visible light and infrared, okay? And before we get into what climate change is, we need to know what climate is and how specifically it's different to weather. So the weather is what you can see happening every day, so the conditions on the Earth day to day. So I'm looking outside right now. The weather is cloudy-ish with some blue skies. Condition on the Earth day by day. E.g., you might say it's sunny, or you might say it's raining, or it's cloudy. Now the climate is different to that, okay? Climate is the weather over a long period of time. And usually that long period of time is about 30 years. So here in England, we say that our climate is temperate. And that means that, you know, it's not really that hot, it's not really that cold compared to other places. It's a bit wet, but it's not as wet as other places. You can get arid, that would be a desert, so it's really, really hot or really, really cold at night, there's no rain. Or tropical, for places like the rainforest, which is very wet, very hot. So there's different types. So it's a kind of general average weather, I should say average up there, average weather over a long period of time, about 30 years. So when we talk about climate change, we're not talking about the weather every day changes. You can't say, oh, it's really hot today, that's global warming. You have to talk about the climate overall. And because it's over a long period of time, it's really hard to measure. Now, the first thing we need to know about is the greenhouse effect. Now, the greenhouse effect is caused by our atmosphere. So our atmosphere, just draw it like this, contains greenhouse gases. This is the atmosphere. And it contains greenhouse gases. Now, greenhouse gases include, everyone's the most famous one, CO2. Also things like sulfur dioxide and things like that. But also, people don't often know, water molecules. Okay, water vapour is a really, really big greenhouse gas. It's probably the most common greenhouse gas, but it's not one that we're increasing, so it's not one we talk about very often. So greenhouse gases have the effect of trapping heat. So we've got the sun here. Now when the sun emits radiation, it comes to Earth. So it emits visible light and UV radiation. I'm going to draw a big arrow like this. Okay, now this, it's a bad arrow, sorry, is UV light and visible radiation. Now most of that comes through to the Earth. So the majority of that gets through to the Earth here, but some of it's reflected, a little bit's reflected. Okay, so it bounces off the atmosphere. Most of it, though, comes through to the Earth. Now, when it comes through to the Earth, as it gets to the ground, it's absorbed. And if you've ever been on a beach in the day, you'll feel like when you can't walk because the sand's too hot. So the sand has been absorbing that UV and visible light. Now, at night, you can walk on the sand because it's cold, it's cooled down. And to cool down, that means it has to have emitted that radiation as, well, re-emitted it. But it re-emits it at a different wavelength. It re-emits it at a longer wavelength. And the longer wavelength is infrared. So it re-emits it like this, as infrared. Okay? That infrared finds it really hard to get out. So a little tiny bit gets out, but most of it bounces back. It's not transmitted like visible light. It's reflected from the atmosphere. So most of it bounces back. And it's absorbed once again. And then it's emitted again. And it's got a bit smaller now, and a little bit goes through, but some of it's absorbed, and you can see that the pattern's going on and on and on. Now, if we didn't have an atmosphere, we wouldn't exist, because the moon is the same distance from the sun as we are, basically, and the temperature on there is like minus 40 degrees, or something like that, okay? It's really cold. Sorry, it's minus 18 degrees, see, got that wrong. It's really cold, and the reason that is because it doesn't have an atmosphere. It doesn't have any greenhouse gases to trap any heat. We do. And that's the reason we can live. The average temperature on Earth, average temp, is about 15 degrees C. So the greenhouse effect is a good thing, except that we've increased the greenhouse gases. We've increased that. And as we've increased that, this means that these bits that are escaping are getting less and less and less. So now, less is escaping, more is being reflected back onto the Earth. So we're trapping the heat more. So what we need to think about for climate change is the enhanced greenhouse effect. Okay, the enhanced greenhouse effect is because we're increasing greenhouse gases. And the main one we're increasing is carbon dioxide, which we'll come on to in a second. But that causes global warming. Because we're trapping more heat, I hope this is readable, we're heating up the air, trapping more heat. Not enough can escape. It used to be that about the same amount escaped eventually as was trapped. So we said it stayed at a steady 15 degrees, but now we're increasing it. So we talked about the worst one being carbon dioxide, and to think about that, we have to think about the carbon cycle. Now, the carbon cycle is a cycle, as you can see, of how carbon is released and trapped in the earth. And part of the carbon cycle is carbon being carbon dioxide. So the easiest thing to think about to start with is here. We've got coal and oil. Coal and oil was formed millions and millions of years ago from plants and animals that had carbon in them, it's carbon-based life. They died and were squashed into layers and layers and layers of rock, and they've become, over millions of years, coal and oil. Now, they are burnt, so when they are they're fossil fuels, and they're often burnt to produce energy. So when I burn fossil fuels, it releases carbon dioxide because they contain carbon. So now I've got CO2 in the atmosphere. Now another process adds CO2 to the atmosphere, and that is respiration. And we can't really do without that, because that is us, making energy and breathing. Us breathing, we're not going to change that, we can't stop doing it, but it adds CO2 to the atmosphere. Luckily, there's some things that take it away, so this can help us. Now, the obvious one that everyone remembers is photosynthesis. That's how plants make their food. They use carbon dioxide and sunlight and water to make energy. Yeah, via glucose. So they use carbon dioxide to make energy. So that traps some of the carbon dioxide in the atmosphere. Another one that people forget about quite a lot is that CO2 is absorbed in the sea. Okay? So most of the CO2 in the atmosphere, or most of the CO2 that's kind of trapped in the earth, is absorbed in the sea. The sea's huge, there's lots and lots of it, it can hold a lot of CO2. The problem is that nowadays we're putting too much in there, so there's too much being burnt, so things like not just factories, also burning forests, that kind of thing, and there's not enough being trapped back, so we're releasing too much, we're cutting trees down, which means there's less photosynthesis, and there's not enough sea to hold it all in. So the carbon cycle helps us explain why CO2 can cycle and why there's some in the atmosphere and what we can do to kind of trap more and to stop more going into the atmosphere. So we need to think about, really, the processes that add carbon dioxide to the atmosphere and the ones that take it away. So we just mentioned that the processes that add carbon dioxide are, firstly, respiration. Now, we cannot stop that. Okay? We need to breathe. Burning fossil fuels. So that's obviously increased over the past 200 years since the Industrial Revolution. So industries, cars, things like that. We've always burnt them, so humans have always burnt fossil fuels for millions of years on their little fires, but now we've got huge scale power stations, cars, we burn them on so much more than we used to. One more is deforestation. Okay, now deforestation is simply where the cutting down of trees. Now, there's two ways this adds carbon dioxide. Firstly, if they burn the tree, then that obviously releases carbon dioxide. But secondly, because you haven't got as many trees, less is going to be trapped by our next thing, which is photosynthesis. Okay, so if we've got less trees, less photosynthesis happens, and that means that one of the processes that takes carbon dioxide away from the atmosphere has been reduced. Now, also, what people are not going to be able to spell this properly, phytoplankton. Now, phytoplankton, I think that might be spelled wrong, is it's kind of like plants. They kind of do photosynthesis, but they live in the sea, okay? And they use the sun and they use carbon dioxide to make energy too. So this is two ways that we can do it. The other thing is, of course, by trapping CO2 in the sea. Trapping CO2 by dissolving it in the sea. So these are the two main things. And you can see they look like they're kind of balanced, but the problem is we're doing too much of this and too much of this, and this can't keep up. So the ones that trap it can't keep up. So therefore we're getting more CO2 in the atmosphere, which is leading to global warming. Now, global warming is leading to something else. So, the enhanced greenhouse effect. Now remember, that's the one where we've got too much carbon dioxide, not just enough. Enhanced greenhouse effect I've done this completely wrong. Excellent. So it shows you how easy it is to mix them up. And I haven't got another sheet, so I'll have to do it quickly here. So climate change is the problem, whereas the climate is changing. Now, that does not mean that everything's getting hotter, okay? Some places are getting colder, some places are getting more wet, some places are getting drier. In England, I think we're going to get colder winters and hotter summers. The hotter summer sounds all right to me, but I don't really want much colder winter. Now, that climate change is caused by global warming, okay? The fact that is that the Earth has increased in temperature by 1 degree over the last 100 years. The temperature's gone up by 1 degree in 100 years. That's not a long time in the grand scheme of the Earth, okay? Now, that global warming is caused eventually by the enhanced greenhouse effect. And that is where we have too much carbon dioxide trapped in the atmosphere, which causes infrared radiation to be trapped inside the atmosphere, which causes global warming. So climate change is caused by global warming, which is caused by the enhanced greenhouse effect. They're not all the same thing, they're all different things. Climate change is the climate changing. Global warming is the Earth warming up. But the enhanced greenhouse effect is that the Earth is trapping more heat, which is causing global warming. So it's very important to think about what the effects of climate change are, okay? Now, the effects of climate change, there's quite a few of them. We're just going to pick out the main ones. Now, one is extreme weather. So this means things like tsunamis, droughts, and floods. And that's because high temperatures will cause more convection in the atmosphere. Okay, and convection is what causes a lot of weather. And there'll also be more evaporation from the sea and also from land because the atmosphere is warmer. So if you have a warmer atmosphere or a warmer place, you know, if you've ever tried to, dry your clothes, that's why evaporation, it happens more on a warm day than on a cold day. The next thing is the one that a lot of people always know about, rising sea levels, okay? Rising sea levels. Now, this happens for two reasons. One, because the ice caps are melting. Now, if the polar ice caps are melting, then the ice stores a lot of water. It's obviously going to go into the sea and increase the level. The second is that also, as we heat up water, heating water causes it to expand. So the sea, as it gets warmer, actually expands and gets bigger. So if it's getting bigger, there's only one way it can really go, which is up. So there's lots of problems there. That means a lot of low-lying countries will be flooded. So I come from Liverpool, and where that is, it's quite low-lying, so we're not very safe. Places especially like Holland, or especially Pakistan and Bangladesh, maybe Bangladesh more than there, where it's very low-lying and they get lots of floods anyway, they're going to be harder hit. Opposite to that is that you'd also get some more drought and desertification. Okay, so drought is where you don't get much water, and desertification is where areas become more like desert. Areas that weren't desert become more desert-like because they don't get enough water. They don't get any water. So things like the Sahara Desert might expand. And the final thing that people often forget about is health issues. So malaria. Now, if it gets hotter, that means mosquitoes can travel more and they can breed in more places. So malaria will travel to more countries, and malaria is a huge killer. That's a really bad thing that we need to look out for. Okay, so there's some really important things that we need to think about for what the effects of climate change are. Then there's also a lot of things that we can do to stop it. Now, the one that everyone knows is stop burning fossil fuels, because that is the main contributor. You can do this by using alternative energy, so energy that doesn't require burning coal, etc. So maybe wind turbines, tidal power, hydroelectric, solar power, loads of things like that. Electric cars, that's a big deal. A lot of the carbon dioxide comes from burning petrol. So the things that we're always told that we should do, I'm sure there's lots more than that, but we'll just keep it there for now. Stop burning fossil fuels, then we'll produce less carbon dioxide. This is what a lot of governments are trying to do, especially this investment in alternative energy. There's also some more technological solutions that we're going to talk a little bit about. One is that maybe power stations might be able to capture CO2, okay? And then pump it back, compress it into a liquid and pump it back under the sea. Now, these ones I'm writing now aren't particularly in use yet, they're being looked into, but maybe capturing the CO2 so we're not releasing it into the atmosphere. Another one that's a bit more out there is spreading iron granules on the seafloor. So spreading iron on seabed or seafloor. Now this helps plankton grow. And plankton, remember we said before, phytoplankton is, here it is, one of the things that takes carbon dioxide away from the atmosphere. So if we can increase plankton, then we can hopefully increase how much carbon dioxide is trapped in the sea, or actually not even trapped in the sea, converted from carbon dioxide into energy. So that's just a couple of things that we can do and that governments are looking into. There's probably loads more that you can think about. This is the main one that everyone always thinks about. Stop burning fossil fuels, try and find different ways of producing energy, because that's the main thing that's causing it. Hopefully now you've got an idea what the difference between climate change, global warming and the greenhouse effect are, and how we can, what it actually means, what the actual effects are going to be and how we can actually stop it. So next we're going to talk about communication with, not with infrared, with radiation. So hopefully that will help.